All right, I think it's time. So we will have this sharing session recorded just so that whoever missed this session, they'll be able to review it online. So anyone, in case you're looking at the screen sharing or the videos, let's welcome Mark from Candide Labs, Candide Wallet. So sorry for that. So on my end, this is Gigi from Antalpha Labs. We are a Web3 developer community. And just in case you don't know, we are having our next Hacker House in Montenegro in May 18th until the 24th. So in collaboration with that, we are having a series of sharings. And the first one, we are welcoming Mark from Candide Wallet to share with us building on a ERC-4337 wallet. But just before Mark could start, I have someone else to introduce, Steve, online for us. He is interning with me. So Steve, would you like to say hi?
Hey everyone, this is Steve. I'm an intern hacker at Antalpha Labs. Roughly that should be it. And I think I can just hand it over to Mark to get us started. And today's session is going to be roughly like 45 minutes. And we're going to start with the sharing roughly 30 or 35 minutes and then leave the last 10 minutes for any questions from all of you in the audience. So feel free to take over from me, Mark. I think your audio might not be working.
Can you hear me now?
Yep.
Awesome. Yeah, I was on mute. So I was saying, yeah, thanks a lot, Steve and Gigi, for the intro. And I'm excited to present a little bit about this session, have a workshop on building 4337 wallets. And before I jump into the presentation, I just want to gauge a little bit the audience and check, for example, ask a question like how many of you are familiar with 4337 and have seen a presentation on the standard itself? I guess you can reply either in the chat or just like unmute and I don't know where's the chat. Yeah, I found it here. All right, we have four out of 19 who have seen a 47 presentation before. 5. If there's at least one who didn't, then we'll go over it a little bit even quicker and give it an introduction on it. All right, so at least more than half of you are new to 4337. So I'll try to also present the standards and giving an overview from a wallet builder perspective. So essentially, this presentation, if you're building a smart contract wallet, these components are the ones that you should be familiar with and you should really care about it. There's a lot of the standard is not simple, but I want to clarify, like as a smart contract wallet builder, you don't need to care about understanding all the details of how the entry point works or how the whole how a bundle works if you're not building a bundle. But it's really important to understand the high level of it so you can like build a 437 wallet. So let's get started. I will first introduce like the type of accounts on Ethereum today, which is the EOA accounts, and you'll be familiar later then like what's a smart contract account. So an EOA account today on Ethereum is essentially a private key that is coupled with an account. So if you own a signer, and you might be familiar with it, then you own an account. If you lose your signer, then you lose your account. That's the nature of EOA account, and it's this coupled relation that a private key generates a public key. the second nature of an EOA account is that it pays its own fees. So whenever you're interacting with Ethereum, you might you tried MetaMask, you always have to have ETH, and you always have to pay it yourself. And validators receive ETH. So if you're, and that's the way gas handling works with on the EOA account. And this the third component is that it's signed with a signature type. It's the ECDSA signature, and it's standardized across all EOAs, and it's one type fit all. And that's the only type of signature that you can use to sign and validate on chain or with EOA accounts. Now, smart accounts or the type of smart contract wallets that we're trying to build is really tries to abstract away the relationship that we talked about, how it's coupled between a key and an account. And that's why really it's called, in my opinion, account abstraction, is that the signer is really abstracted away from the account. It's a signer controls an account, but it's no longer like, if you lose a signer, it doesn't necessarily mean you lose the account. It can be secured by other types of signature. So you don't need to use the ECDSA method with EOA accounts necessarily. You can use different types of signature, and we'll talk about the possibilities later on. A smart account is essentially a contract account, and something I didn't clarify it is that smart contract accounts cannot initiate transactions, and that's why we have all this 47 standard on Ethereum, is that a smart contract account just cannot initiate a transaction, and that's why we need all these components so that we can actually make it. A contract account also doesn't need to maintain an ETH balance to start. Okay, we're back. So here's the first slide about EOA accounts. We talked about the relationship with the signer, basis on these, and the approval. That's the second slide about smart account, and we stopped at maintaining a balance for a smart account doesn't need to maintain a balance because someone else can pay the gas for it. So you can of course imagine that there's you might have heard of the component paymasters, which sponsors transactions on behalf of an account, and that way you can have all this better onboarding. Whatever, if you try to someone creates a new account, they don't need to know what is ETH. They can just like start transacting with stable coins, for example, and we'll talk about the applications on that. And then the third, a smart account, you might have seen that you always have to approve one transaction at a time with an EOA. If you think of Uniswap, if you ever traded an ERC-20 back to another one, you always need to approve and then deposit. And it's a two-click experience. But with a smart account, you can change the execution to have a batch execution, so that you can instead of approving one by one, you can like approve both, and they can be atomic as well. So that way, if one fails, all the transaction fails. That is indeed helpful if you are that it doesn't leave open approval. If you say, for example, I'm going to approve an allowance for a contract with 100 DAI and then deposit, and then if the deposit fails, then the approval doesn't remain open, and you're only and it's revoked. And that's one of the benefits of having an execution batch of transactions instead. So I want you to see the potential of account abstraction in general, and each components on the slides honestly deserve like its own slide, and I am not going to go over them very quickly. You might be familiar with them already, since you're interested in 47 and building a smart contract wallet. But essentially, with a smart contract wallet, you can the first thing that is very exciting, at least to us at Candide Wallet, is that you can use your phone as a hardware wallet because of the possibility that you can use a different signature scheme instead of the ECDSA, so that you can sign with the secure enclave of your phone if it supports it. And a lot of phones supports it today, not all of them, starting from iPhone 5, for example, and then certain Google Android phones, like I think the Pixel does support it, and but not all Androids. But it's very powerful, right? If you think about it, the experience from a user perspective, it doesn't change. Most wallets today, they let you like make a password and just like use a Touch ID, and then you're logged in. But the way the phone secures the key or is different, and it changes all from a security perspective. It's essentially you're owning a ledger, but with your phone. So that's one of the things that we're very excited about. The second thing is that you can have a 2FA. Imagine you have a second signer on the contract, and you try to validate each transaction. If it's, for example, a vault, then you can use a 2FA as a security measure for the accounts, and that way. And 2FA is actually it's a challenge to implement in a decentralized way. You can implement it in a very centralized way, and it works fine. But it's one of the challenges to implement it in a very decentralized way, in a way that on-chain pretty much. So if you're looking to build that, then I think you should look into how you can, for example, offer on-chain 2FAs for other wallets to leverage. Onboarding, we talked about this. Instead of having the user get started and with some ETH or other, you can sponsor completely if you're in a very low network fees like Polygon or Gnosis Safe. It makes sense today. On rollups, as they start scaling, it might get cheaper. You'd be interested to sponsor their entire transaction, and you just need to implement the way so that you don't get spammed. You don't want people to or attackers to you need mechanism to know if a user is a legit user, or if just trying to spam you with an empty your account that you're sponsoring with. You can let them pay in stable coins, like we mentioned. We'll talk about paymasters later on. Session keys, you can session keys. They also deserve their own presentation, but essentially you can give temporary access to certain contract limitation. For example, if you're playing a game, you don't want to give the game access to your vault, right? You just want them to give limited access to a certain allowance. For example, I'm going to play a game for an hour with 5 DAI, and they can do whatever they want. I don't need to click again, approve. They can do whatever they want with. And for an hour, they can do whatever they want with 5 DAI. And session keys are quite important for low level, I guess, important financial application. For example, a game, you might be interested in session keys for other applications that are, I guess, not in DeFi space. And then the last one that I want you to get excited with is subscription. Today, not a lot of you can go to shopping and there's no checkout with crypto until today, because one, the user need to pay gas. Two, there's a lot of on-ramp fees. But I guess with account abstraction, it doesn't solve the on-ramp fees, but maybe someone is going to solve it one day so that you can offer an easy on-ramp for merchants. And you can also offer subscriptions for services like Spotify, for example, where instead of and you can give an allowance and a recurrent charge so that the service can charge an account on a recurring basis. You can see some applications that use some sort of subscription is DCA, dollar cost average applications. There's some of them on that are implemented today, and you can get inspired for them. It's essentially the same idea. Every month, the user have in a contract, and they select an amount to either buy or sell, for example, ETH to DAI, and it's a way for investors to buy ETH or sell ETH on a recurring basis, and that's the same idea. And they also implement a contract account, but if the user already have a contract, which is their account, then they don't need to implement they don't need to use a MetaMask plus an account, right? That's the idea of Abstraction. So now all this to get you excited to build for 4337. Something I didn't mention as well, 4337 is specific to Ethereum and EVM equivalent chain. The whole idea is not to introduce, when the Infinitism team decided to work on the standard, they said one thing: we don't want to introduce any changes to the protocol, because historically there have been many attempts to introduce smart contract wallets level in the protocol itself, and there hasn't been any agreement, so that standard just say, hey, we're not going to change anything in the protocol. We're going to do all this higher level infrastructure so the others can build smart contract wallets. And if once a few upgrades later, if everything's working well, then we can introduce the change to the protocol later on. So that's 4337 is a higher level infrastructure for smart contract wallets. There's different account abstractions. For example, ZK Sync and StarkNet. They introduce it in the protocol level, which I think also is a very good idea to experiment, because natively, and it's very inspired by 47 as well. So to get started, as a smart contract wallet builder, there's 4 components that you need to care about in order to build a wallet. 1, you need an account implementation, and the account needs to interact with the entry point contract. And we'll talk about a bit about the method that you need. You need to be a little bit familiar with the entry point contract, because that's the one that that's the contract that interacts with the contract that you're going to be building on. And the entry point contract is a global contract that essentially orchestrates transactions for all accounts. The third component is bonders, which, as simple as it is a software that process a new type of transaction called user operation, and you might have heard of it if you're familiar. And they take this new type of transaction called user operation, they process it, and they bundle multiple of them together, and their job is really to take it and then submits it to on-chain. The fourth component is paymasters, which simply are contracts that are responsible for paying gas. That's the component that you'll need if you want to have gasless transactions in your account, or if you want to support a token paymaster, which is the let users pay in a stable coin or other token as well. So how does it really work? Essentially, you have you start with your app, right? I specifically don't want you to think about the signer as a mobile app or a web app, because I don't want you to be limited with your imagination, because a wallet can also be just invisible, right? And I'll talk about this later on. But whenever you sign up to an account on Gmail, for example, you don't come up with a different app and say, hey, you need a Google account. You just sign up for Gmail, right? You can also build a wallet like this. That is, and there's many there's others who are building it like Zero Depth and Zero XPass, and also Ledger is building an invisible wallet, what they call. But what ultimately is that piece of software is an app that that have a way to sign user operations, and it construct the user operation and display it to the user so that the user is aware of what's going on at least. And then the software just like submits the user operation to the bundler. Today, bundlers operate independently because the mempool is being, we talked about the bundler mempool, it's being developed. So essentially a bundler takes, many bundlers just like take the user operation. They do like bundle them together, and then they send it to the entry point. What happens is that the entry points have a few steps for verification and execution, and these two are very separated, and it's clear in the standard that the verification and the execution is separated. The first step is that the entry point call and on the contract and contract account and verify the signature. And if there's a paymaster, it also verify the paymaster if it's half staked. Then if the user like, and we'll talk about the different paymaster types as well. But for example, if a paymaster is a deposit paymaster, then it needs to stake, which say, okay, I'm gonna give you 1 ETH in the entry point, and I'm gonna sponsor users transaction. So the entry point verifies that the paymaster has indeed like staked inside the entry point, and then the validation happens also on chain. So the entry point calls number 3, validates user up, validate paymaster user up, and then the 4th component, it actually execute the operation for the account. And if there's and then the 5th step is a post operation for the paymaster. If the paymaster is being, for example, paid in an ERC-20, or if there's leftover, then the post office is being called so that the leftover is transferred to the account. I talked about 4 components originally: the accounts, contract, the entry point, the bundler, and the paymaster. But the number 0 component that you, as a wallet builder, you wanna build a signer app, and it's either a mobile app, it's a web app, it could be an invisible app. That it's gonna be up to you. And its role, essentially, 1, construct the user operation. I didn't talk what's inside the user operation, but essentially it's a new type of transaction that has all the elements needed so that this new your smart contract wallet can work. It has the sender, it has the nonce, it has the signature, so that your app needs to be able to construct a user operation, and that's essentially like the construct and sign it. Number 2 is sign and add the signature inside the user operation field, like object. And then 3 submits it. So your app will be connected to a bundler endpoint, and it's going to say, hey, I'm going to send the user operation signed to the bundler. If you want to give it a try with some apps, there's like many projects and companies are building SDKs and examples for wallets. I've listed like if you're building a mobile wallet, you can check out Candide mobile wallet. It's open source, and you can try it out. And if you're more familiar with web apps, and if it's easier for you, I encourage you to try Trampoline. It's a browser extension by Infinitism team, and it's built by Garvit. And essentially, it has a very simple way to show you how to deploy an account, construct a user operation, and it has I think it has a paymaster. I haven't tried it yet. It also have a paymaster, and it does interact with the API that Infinitizen team built around the entry point contract. So if you're just getting started and you want to like experiment with it, I encourage you to check the browser extension. If you're building a mobile wallet and if you're committed to building a mobile wallet, I encourage you to check out the Candide mobile app and try experimenting with it as well. Now, getting back to the account implementation. Essentially, like we said, the account needs to have just two methods that you need to be taking care of it: the validation method and the execution method. And that's these two methods, you need to export them so that the entry point can call. I'll give you an example here. Candide wallet contracts have 4 methods. Why? The third one, which actually is the first one, is the setup method. Essentially, you have a setup method that sets the contracts, and it calls the execution so that you can set up the account and deploy it. Candide wallet contracts uses safe as its base, and I specify safe because it's not a direct implementation of safe. It's a modified safe so that it can work with the entry point contract. If you see other contracts that are great, for example, I can encourage you to check out the Argent wallet contracts. They don't advertise it a lot, but you can also use Argent wallet contracts to build a 437 wallet and leverage the bundler networks and the paymaster contracts that are already built, so you can build your own version of Argent wallet. You can build on safe like we did. You can check out Ember wallets. They also have open contracts that you can like experiment with. And essentially, you need to add in these 2 methods to it so it can work with the entry point contract: the validate and execution. The last method that we have is replace. Like you have seen, the entry point contract got upgraded. It was not a security issue by itself, but there was like some things that needed to be changed, so it got upgraded. And here, our account has a replace method, and it simply replace the old entry point with the new entry point, so it can point to the new one. And that's always, we build it so that the user have the choice to upgrade or not. From our perspective at Candide Wallet, we really care about self-custody and the ability for users to make their own options. We never execute anything on their behalf. We never, the signer is always offline on their phone. And if the user wants to replace the entry point and say, hey, I want to upgrade, we're going to actually prompt them to do so and tell them, hey, we want to upgrade. And they have the ability to do so. If they don't, then it's their option. Obviously, as a wallet builder, you're going to say, hey, how I'm going to maintain like different entry point contracts and others. It's in their advantage to upgrade, and then you can support it on your interface for some time, until you can say, hey, the user they'll still be able to access their account and they can like transfer out, but they cannot like do, I guess, like daily operations after that. The third component, bundlers. So as a wallet builder, you don't really care about building your own bundlers, because there's a lot of bundlers now. There's like the Infinitizen bundle in TypeScript. There's EtherSpot bundler, also in TypeScript. There's a Rust bundler you can use. There's a Python bundler that's that one we built. It's called Voltaire. Sorry, a Rust bundler we didn't build. We built a Python bundler called Voltaire, and the Rust bundler is built by Vid. Right now, if you want to run, there's 2 ways to use a bundler. You can either run one of them locally, or you can use an endpoint. And to make it easy, we have public endpoints that are free to use on testnet. So if you scan this QR code, you're going to see that we support Sepolia at the moment, and we'll be supporting Goerli. And depending on other, like if you see other networks on testnet that you'd like to support, we'll work on supporting other networks depending on demand. That's the two ways you really, essentially it's an endpoint. All you need is either run it locally, get the endpoint from your local machine, or use a hosted endpoint by one of the providers. So the last slide is on paymasters, which is the fourth component that you'd be interested in. There's the type of paymasters, like we mentioned, are either you can sponsor all users' gas, or you can let users pay in a stable coin, which is the token paymaster, which is kind of a hybrid between a verifying paymaster and a deposit paymaster. Verifying paymasters essentially use off-chain logic to sign the user operations, so that and the deposit paymaster is on-chain. So the deposit paymaster just say, hey, I'm going to deposit the entry point, and whenever the user like make a transaction, I'll sponsor it, and they need to have it to be staked in the entry point. And now it's demo time. So I'm going to show you an example of what a smart contract wallet can look like. I'm going to show you a mobile, our Candide wallet, and an operation that uses a paymaster to sponsor. I'm going to open the video. I actually recorded it so that my computer doesn't explode with everything running. Oh, here we go. Can you still see my screen and the video?
Yeah, I think so. We see the wallet interface. It's like in the phone shape.
Awesome. Yeah, so here's an operation that that actually make use of two features. One, the paymaster, and two, secure in the wallet with a different type of instead of showing the seed phrase to the user, we use what is known as social recovery, and I'll show you a little bit. So essentially, instead of showing the user like a private seed phrase, you can have a recovery context or trusted context. And essentially, when the user loses their phone, all they need is let their contact know that they need to recover their account to a different mobile phone, which is a different signer. So here we show that user can just like set up an address, and it could be any address, just needs to make it like compatible with other wallets. It needs to be on the same network as the account. So if you're doing on Optimism, the other account needs to have access to a wallet on Optimism. You give it a local nickname. We don't store any nicknames on the wallet, so the account is completely private. And here you can see that the account doesn't have ETH at all, and we use a token paymaster to let the user pay with a different token. Here we have a test token called CTT, but you can use stablecoin on mainnet. I guess we can start with questions if you need, and I'll try to answer them.
So there are actually questions in the chat. We briefly discussed it, but I also want to hear your take on it. So Caleb asked if there's any incentive to provide bondware as a service.
Yes. So essentially, the bonders, you can think of it as the same way as block builders, if you're familiar, or validators. They work to take a fee. They take a priority fee, and if they do work with block builders, then they can on Ethereum mainnet, then they can capture MEV. So the bonder has an incentive to provide their service, and because they take a fee. If you want to run a bonder, you can always take one of the implementations of the bonders, and whenever the mempool is out, then you can participate as a bonder software, as a bonder to capture fees and offer this service to bundle user operation and submits them on chain.
Yeah, that definitely makes sense. Actually, as a follow-up, I'm also personally wondering, you mentioned you can potentially also be the block builder as a bundler. So is it more like always the case, or can you just be like a standalone type of bundler then, which is not a block builder?
No, it's not always the case. You don't need, you don't need to be a block builder to become a bundler, to run a bundler software. And a block builder doesn't need to run a bundler software to operate, of course. But it makes sense more from a block builder perspective to run a bundler software, because they have instead of like taking user operation from other bundlers, they can just run their own bundler, and they can, like, instead of paying a fee to the person that is running the bundler, they can like cut another middleman, and they can do it by themselves.
Sounds good. And we have a next question in the chat, which is asking, what is the requirement for running a bundler?
So Infinitism team have set up so for running a bundler, what is the specific
requirements?
Okay, so if you're talking from a machine perspective, the only requirement to run a bundler is if you want to run a bundler software that is already made, then you need a full node. So if you run a full node, and that's pretty much it. You can run a bundler, and you also need to start off with some ETH in the account so that you can pay. But technically, if the bundler software is well written, then it should be making more than they're losing. So that's the requirement. From a person who's building a bundler, there's specific requirements and test suits that needs to pass in order to protect it and also work with other bundlers in the mempool. So that's a different topic. And there's I can share links to the specification and all the bundlers that are working on, and it's a different topic.
Sounds good. Thank you. And Yuanfang has a question in the chat asking if there's going to be a different type of bundlers to specific type of user operations. And if yes, do you have any examples?
I don't think so. There's so different types of user operations. I don't know, actually. I think for now, like, I guess this is a futuristic question. So for now, like all your user operation are like standardized, right? You have a user operation. It has all the information for the account. It has the signature. It has the paymaster if it's like being sponsored. It has the nonce, and you send it to a bundler endpoint. I guess a bundler can say, okay, I'm going to offer, like we mentioned, it's going to work with BlockBerry, so it can be a private endpoint. And a bundler can say, hey, I offer something like a MEV boost or flash bots, and say, hey, if you send me, it's going to be private, and I'm not going to front run you. But it doesn't change from user operation perspective, unless someone else has a different opinion. Maybe I see Sharif as well from the team is here, so maybe you can comment.
Yes, hello. Every bundler should be able to process any type of user operation for now. Yeah. Can you hear me?
Yeah, I can hear you. Makes sense.
Yeah.
Yeah.
Thank you. We don't have any more questions in the chat, but in case people have anything, feel free just to unmute yourself. I think Iyasu, sorry if I mispronounced your name, but ask another question in the chat just now. Is flash loan possible with ERC-4337?
flash loans. So flash loans is a different subject, because whenever I think of flash loans is essentially interacting with a contract and doing one transaction, I guess, and you borrow a loan from one person, and you actually promise to return it, and you take the cut. Is it possible with ERC-47? You mean, is it possible to someone steal an account implementation?
I think might be to the point of if it's possible doing flash loan with a user operation transaction as opposed to like a regular transaction. Is that what you're trying to ask, Yasu?
Yeah. Yes, hello. Yeah, I believe it can be possible. There is no problem. Yeah, with executing a transaction. Also, using ERC-4337, you can actually bundle many operations together and send them and sign them once. So these types of operations for DeFi, it can be much easier for the user.
Hi, I have a question.
Mhm.
So if the bundler can arrange the transaction order, like sequence as like whatever they want, how do we protect MEV for bundlers? Like how do bundlers prove that they're honest, they're not rearrange the transactions order?
Go ahead, Chief.
Yeah, mainly all these challenges are exactly the same for the Ethereum nodes. You know, it will be exactly like the Ethereum nodes. How Ethereum nodes cooperate, how they protect against rearrangement. It will be exactly like Ethereum nodes. So yeah. So there will be, maybe there will be private bundlers, maybe there will be general mempools. Mempools, it will have it will have a repetition system, you know. So bad bundlers will be punished. It will be expelled from the mempool. Good bundlers will stay. So yeah, it will be a dynamic system, and it will have the same challenges as the Ethereum execution nodes. Yeah.
But the validation nodes are distributed. Like even you want to have MEV, you need to like have flash bolts, which is very expensive. But bundlers are more centralized.
Yeah,
so it's very hard to detect.
No, it's only centralized right now because the B2B protocol is not developed yet, but it is designed to be decentralized. So there will be a general mempool, and it will be decentralized, and there will be multiple bundlers. So you can send your user operation to only bundler, and so you will communicate the user operation with each other exactly like the execution clients and the for the execution clients like guests, you know. So it will be exactly like that. For now, it's private because the B2B protocol is not finished yet. We are working on it.
So the P2P protocol decides which nodes to have the ability to, you know, send the transaction to the mainnet. Is that
mainly,
like?
Yeah, you will send your user operation to like any endpoint, exactly like if you are sending a normal transaction, and each bundle and the bundler that will receive the endpoint will first validate the user operation, then it will broadcast it to all other bundlers. So you know, then the bundlers can collect the user operations and send them to the block builder as a bundle. So it will be a decentralized system. This is the main feature of the bundler or the mempool. It will be decentralized, but it can also be private for whatever purpose. Bundler operators can be a private mempool, but the default implementation, it should be part of a public mempool.
Gotcha. So it will be some kind of staking thing for the bundlers, right?
Staking? No. There is no staking.
I
You
see.
mean
Thank
staking
you.
like
So we will have some kind of staking service for the bundlers as well. So bundlers, they have to stake to be able to publish transactions.
yeah, there is okay. If you are talking about staking like an Ethereum validator, is this what you mean? Staking is 32 ETH, you have to stake 32 ETH to get your reward, right?
Yeah, I think
Or you
this
mean
is what
staking
we
is the entry point? Okay, generally, hello?
Yeah, can hear you.
Yeah, there is no staking in the same way as validators, that you need to stake 32 ETH to get your reward. No, you don't need to stake 32 ETH or an exact amount, but there is other type of staking that you can do, that you can stake for the in the entry point. The paymaster can stake, the users can stake to gain some certain features. So it's staking in the entry point is much different than staking for the validators. Yeah,
One more
and
question. So if I send transactions, sorry.
Yeah, sure.
One more question. So if I send 2 transactions to like 2 different bundlers, and how like the EIP, like the protocol will prevent double spend. I know you won't double spend, like how it will panic or like, you know, report the error.
Report an error for the user operation?
Yeah, so suppose you have 2 bundlers and I send 2 transactions to different bundlers, the same transaction to different bundlers, and they all post the transaction to the mainnet. And so what happens afterwards? Okay, if you sending the same user operations, this means that they will have the same nonce. So let's say that the bundlers should be each bundler should firstly check if the user operations is already included or not, because if it will send it and it's already included, it will fail. Okay, so let's say they are not cooperating. So the second user operation will send by the bundler will fail because it will have the same nonce. It will not execute. Gotcha. So the in the entry point, or they were like basically just stop that transaction because they found that the transaction has like nonce +1 already, right? Sure. Firstly, the entry point will prevent it because of the nonce. Also, the user, the account itself, it will also fail because it's the account, the smart contract account. It will also fail because it will need to increment the nonce. Sure. Yeah.
Okay, so we are kind of over time here by 5 minutes and want to be respectful of the time. And just wondering, in case people have more questions, Mark and Sheriff, do you mind maybe dropping some contact info?
I do have more questions.
That's fine with you.
Yes, sorry to interrupt.
Yeah, we can.
Yeah,
do you still have time?
Go ahead.
All right. Thank you. I'm just a little bit confused with the, normal Ethereum's validator's role here. And does the validator still has to, validate the user operation transaction?
So something I guess we didn't clarify is that the bundler sends a normal Ethereum transaction. The bundler, this is their role: take user operation, multiple ones, bundle them together, and actually like push out a normal Ethereum transaction. And then they send it to the node that they're connected to, or if they're running their own node, or to another RPC endpoint. So that's the validator just receives a normal Ethereum transaction. It doesn't care about user operation. Doesn't care what's inside it, because that's the bundler's job: convert type of user operations into normal Ethereum transaction.
Okay, so the mechanism actually works like the bundler send out a bundle of user operation to the validators, and the validators, do they process the, the transaction and actually to validate them, or no?
Yeah, so they work like any other like Ethereum transaction. Essentially, the bunder's role is to make sure that whenever they're gonna pay fees for it, they know that the entry point like protects them, and then they check all the they check the signature, they check if the paymaster has stake. They don't want to like execute a transaction that is failing, right? They don't want to fail it on chain. And then like whenever you send an Ethereum transaction, it's just like any other normal. You can think of it as any other normal Ethereum transaction. It's not gonna. There's nothing special from I guess from running a node perspective. Like it's a normal Ethereum transaction. If that makes sense.
Yeah, that makes sense. So the transaction goes to the validator, and the validator kind of proposed the transaction, and that transaction was sent to the entry point contract. Is the right flow I'm getting?
Is it the right flow? Can you repeat the flow again?
So bundlers to validators, and validator proposed the transaction, and the transaction was sent to the
On-chain,
entry point
yeah.
contract.
I think so. Yeah. Thank you. That.
Sorry, I have one more question. So I know that the account abstraction heavily depends on the BLS signature verification for a group of signatures. What's the capacity right now? How many signatures address it can verify for one bundle? So like basically how many transactions can be there in one bundle?
Which BLS implementation are you referring to?
Because like once you have a bundle of transactions like sent to the Ethereum mainnet, right? And suppose you have 100 signatures, then the BLS library will basically verify the 100 signatures at once. So what's the capacity for the BLS library to verify? Like how many signatures can be verified at most in one transaction of a bundle?
I guess it depends on your implementation. We do have like an experimental implementation of BLS. I guess Sharif can talk about it, but it depends on your implementation, right? It's not specific to like it's not a fixed number.
Yeah, exactly. First, BLS transactions are only not all user operations using BLS. So some user operation use BLS, and some user operation doesn't use BLS. And mainly the number of user operation per bundle, it will mainly depend on the gas limit for the block. It will depend every bundler. It will have to calculate what is the most profitable number of user operations per bundle. There is no hard limit.
Does that make
Gotcha.
sense?
Thank you.
Yeah. And then I think there's a Jesse or Jess is kind of using or planning to use infinitesimal entry point. Yes. So the entry point is actually the advantage from a smart contract wallet builder is that the entry point is audited and everyone trusts it. And it's everyone advantage to use the same singleton of the entry point contract. So right now we're actually using the previously version 0.5 of the entry point. It got recently updated, and then we're gonna work on making sure that Candide Wallet supports the new entry point, and also our bundler Voltaire supports the new entry point. But it's interesting that our conversation is more about the bundle than the smart contract wallet, which well, maybe we can have a different session on if anyone is interested in running bundlers or building another bundler, we can have another one as well.
That sounds good. And actually, just on the prior point, I think you mentioned in the presentation that the user have the choice to change the entry point contract, but they also mentioned like it's like a single contract on the like Ethereum itself. So I just wonder like what's going on here?
Yeah, so the first version of the entry point was deployed a few weeks ago, maybe a month at ETH Denver. I think it was like a month, or I don't remember what happened when it happened. but it got deployed and it was audited by OpenZeppelin, and everyone started to use it. And then there was a few like upgrades to the contract, and the contract essentially got redeployed to a different address, and everyone agreed that, hey, we fixed some issues with not related to users account, but different services that use the entry point contract, like explorers, or yeah, mainly I guess explorers display or other, and that's why they made I guess they made a slight fix for that, and they say, hey, we have a new version of the entry point contract, please use it. And the changes was audited by OpenZeppelin, and now we have a new entry point contract, 0.6, I guess, 0.006.
Sounds good. Just scanning through quickly. I don't think we're missing any additional question.
Anyone have questions about building contract mobile, or I mean, smart contract wallets?
Okay, I have a question about the paymaster.
Okay.
Okay, so I want to ask about how you handle the approval process for the paymaster. I mean, when a user wants to make a transaction with an ERC-20 gas sponsor with a paymaster, they need to complete an approval transaction before, like an ERC-20 approve. They need to approve for the paymaster contract to use their token, right?
Yeah.
So, however, is that approve transaction itself need a previous approve. Does it make sense?
Yeah, I think you have a good question, and we actually have an answer. I'll let Sharif answer because we discussed this previously.
Yeah, we're talking about the approve function, right?
Yes, the approval for the paymaster to use the ERC-20.
Yeah. It's mainly you have multiple types of paymaster. One of them is the verifying paymaster. So what you do is generally you will send your user operation to a paymaster RPC endpoint that will approve that okay, maybe one type of paymaster, it can sponsor your whole transaction. So you will send it to a backend that will approve the user operations, and it will add the signature for the paymaster verifier. This way you can include the signature and send it to entry point.
You got muted.
The entry point in this validation function will check this signature so that it can pay for the gas. Also, this function can also check for the user operation validation time range. It can put time range for this validation. So look, like from this time to this time. Yeah, so it can do multiple validation that depends on the paymaster implementation.
Yeah, but generally, I think that my question, the term approve in my question is about the approve function of the ERC-20 token. I mean, if I want to transfer an amount of token by using a smart contract wallet, right? I need to make an approve for the paymaster, not paymaster approve for my transaction, right? So I need to approve the amount of token for paymaster to use for the post op, right?
Sure. Yeah, if you are using a token paymaster, if you want to pay by ERC-20, you need to send firstly, you need to send an approval first. Yeah, you're right.
So the first transaction, it must be the approve, and and the paymaster have to sponsor all the gas fee for it in case that the smart contract wallet were not deployed yet.
So essentially, since you own a smart contract wallet, you can all implement it in the same transaction, right? So you send the approval in the same. If the contract is not deployed, you actually send it so that the paymaster in the post-up operation gets paid in the ERC-20, and you include the approval in the same transaction, if that makes sense. Because I think you're thinking in terms of EOA and not a smart contract. If you think from a smart contract perspective, you can always like batch transactions and put the approval in the same transaction as your second one.
Yeah, it makes sense that we can send a batch transaction, but in the validate function of paymaster, it have to check the approval first. So so in the execute part, it cannot run the approve because it fail in the validate part. It's going to be fail in the validate part of the paymaster if we wasn't approve it.
Yeah, go ahead, Sharif.
Okay, if you want to, firstly, there is multiple types of paymaster. So let's say you want to implement a paymaster that checks for the allowance of the paymaster for this for certain account. Okay, so you can check for allowance only. Check for allowance in the validation function, and then in the execution function, you can actually do multiple sequential operations. Okay, so you can firstly approve, and then execute your transaction. Also, if you want to, you can check out actually our wallet implementation. We have a field. With each execute function that you can automatically approve the amount you want to approve for the paymaster with each user operations without even doing a batch without even doing a bundle. If you want to check, you can check our GitHub repo, Candide Wallet, and you will see the execute function. It will have it has a field for the paymaster approval. So this is all. It can depend on the there is multiple types of paymasters and multiple types of implementations. You can check our paymaster implementation. You will find, I guess, what you want. You can also check the paymaster implementations in the Infinitism and the other tool. So you find multiple implementations.
So in summary, it's a limitation from now.
It depends what you mean exactly. If you want to send an approval with the same transaction, you can do in the same transaction. It will be a bundle transaction. You can check. I guess that's what you mean, right?
Okay. Let me check the GitHub.
Yeah.
Thanks for the answer.
Yeah, I guess I can clarify. I know what you mean. Like, so essentially, the paymaster is gonna know that if the bundle of transactions is gonna be approved, they don't need to like approve and then send the transaction on chain and then let them pay. If you think of yeah, I think if you think of bundles, it's gonna make sense from a contract account perspective. So the paymasters yeah, they will know that they're gonna be paid at the end of the post operation.
Thank you.
Yeah, these are great questions. Do we have more questions on bundlers or smart contracts or paymasters? We can answer them. And
I don't see them in the chat anymore. Do you guys still have time or what's?
Yeah, we can say a few other minutes if people have questions. No worries.
Actually, if that's the case, then I have a question,
Sure.
which is actually related to the smart contract wallet. So I think you mentioned earlier that there's a setup function in the wallet contract that's called like at the start of the wallet creation, but I know there's also a wallet factory interface in defining ERC-4337. So I just wonder, are you guys like intentionally not implementing that, and what's the reason for doing a setup function versus the wallet factory?
Sorry, can you repeat? SLL function? Can you repeat again? Sorry.
I think it's called the setup function in the in one of your slides for like creating a new wallet.
Yes.
And I know there's also like a wallet factory interface for ERC-4337. And are you guys like using the setup function instead of the wallet factory, and what's the reason for that?
So if you're talking from an account perspective, each you can Infinitism have some examples of accounts that you can start experimenting with. They have a they essentially have a base account and a simple account, but you can also like make use of other accounts, if that makes sense. You can use you can build your own. You can use others' accounts, like I mentioned, like Safe or Argent. So if that's the factory of the account is that you're talking about, then yes, there's a few examples of accounts that Infinitism team built, so you can start experimenting with. But ultimately, it's up to you to decide if you wanna, as a smart contract wallet builder, you write your own implementation, or you use an already existing implementation, like we did, we used Safe as our implementation.
I think Mark is asking about the setup function in our contract wallet. You know, the setup function.
Yeah.
For the safe base. So this is so this is different than the contract factory. This is only setup function initialize the owners. You know, it's only initialize the owners. But the contract factory is another thing. The contract factory generates proxies. So these are two different things. The setup function it relates to the safe because our wallet is based on safes. So the setup function it's mainly the equivalent of the safe contract setup function.
Yeah, makes sense. Thank you for explaining that. Yeah, I don't think there's any more question going on in the chat. And okay, so thank you so much for being here. And for the audiences, in case you have like additional questions, we also posted the link for Antalpha Labs Telegram group in the chat. Definitely join it and interact with the great AA audiences. And again, we also have the Hacker House going on at Montenegro starting in May 9th, and our application is open for the hackers. The link is also in the chat, so feel free to click on that. And without further ado, let's definitely give a round of applause to Mark and Sheriff for this like amazing session and also the great questions all of you asked. Thank you so much for being with us today.
Thank you so much for having us. And if you have more questions, feel free to ask. And we just joined the Telegram group as well, so you can ask there. If you need any help with building smart contract wallets, bundles, or Paymaster, we have you covered. So like, feel free to engage us.
Sounds good. Thank you so much.
Right.
Have a great rest of your day or night, everyone.
Thank you. Take care.